So I'd like to start by saying thank you everyone for coming. My name is Cody Armstrong, and our topic today is basics of design intent. What I'd like to do today is show you a few different examples of design intent and how big of an impact it can have on your design, and in particular how your design changes. So basics of design intent, really intended for those new users trying to understand, when I make a change, why does it behave this way? What impact do the decisions that I make have on my design? As I always say with these webinars, we really encourage you to ask any questions that you have. So feel free to type in any questions into the questions panel in your GoToWebinar dialog. I'll do my best from time to time to stop and make sure to address them. If I don't answer your question, make sure to stick around. After the end of the webinar, I'll make sure to stick around and answer any questions that I haven't. So again, feel free to type anything in as we're going through this. Now, before I get started, there are a few things I'd like to mention about Onshape in general before we get into the topic of the day. And the first is our mission. And if you're new to Onshape, our goal with Onshape is getting everyone working together with CAD on any device, anywhere. And if you haven't used our mobile apps, and iOS app, so you have accessibility from iPads or iPhones, or Android apps, Android tablets, Android phones, we really want to give you access to your CAD data from anywhere. And this also includes full-blown CAD editing capabilities. So our mobile apps are not just viewers, but actual editors. You have the real ability to build parts natively, assemblies, and so on in a mobile device. So really need to check out if you haven't tried our mobile apps. But the other point I want to make with this is accessibility from any computer with a modern browser. This is Mac, Windows, Linux, Chromebooks. So, as long as it has internet access and a modern browser, you have access to your CAD data. So getting everyone working together with CAD on any device, anywhere. Now, the other point I always like to make is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's really three pieces: parts, assemblies, and drawings. Now, we do have all three major pieces. The things about Onshape that are unique are they're evolving very quickly. You'll see updates to Onshape roughly every 3 weeks with new functionality added, and really nothing for the user, in terms of, work. You just log in and you see new features. Some other things that really set Onshape apart is one of them is, of course, built-in version control. With Onshape, you don't have to have a separate version management system. It's built into the core functionality of Onshape. We can also read and write common CAD formats. So if you've come from another CAD system, if you have a CAD data in another format, IGES Parasolid, SolidWorks, Inventor, a number of different formats that we can both import and export. So definitely worth trying if you have a library of CAD data. That also includes DXF and DWGs as well. So read and write common CAD formats. The last thing I want to mention is entirely new methods of collaboration. So if you haven't shared your document yet, real-time simultaneous collaboration, building an assembly together, building a part together in real time over the web is really a neat thing. So definitely try out our share capabilities, really add a whole nother layer of collaboration to CAD. So those are the things about Onshape I like to mention in general, especially for those new users out there that may just be taking a look for the first time. So what are we going to talk about today? Well, the goals for today is really to explain design intent, and I want to do my best to explain design intent and what it means to the new user that's just getting started, understanding what these decisions mean when you make design changes. So why is this so important? And what can we do to show the correct intent? And so a lot of this, what it has to do is, showing what's wrong and what can be done to fix it. So if I make the wrong choice in terms of design intent, what are the effects? And then what can I do to fix that going forward? I have just a few different examples to show you. And as I always say with these, again, feel free to ask any questions as I'm going through this, and I'll do my best to stop and address them. Okay, so enough slides. I'm going to jump right into it. Now, forgive me, one more slide. What is design intent? Now, it sounds simple. It's the intent of your design. That's a very easy way to explain it. But of course, what does that mean? And I think it can really be summed up by how your model behaves to change. So if you make a design change, how do the features rebuild? What's the location, and do they correctly reflect your intent, your goals? So how your model behaves to change is important. If you've ever made a change and all of a sudden these features don't rebuild the way you'd expect, chances are the design intent was either not correct or just not the right option. So what are the effects? What can happen if you get it wrong? And then how can we fix it? So let's jump into it. Now, I mentioned before I've got a number of different examples for you. We're going to start really simple, and I think a lot of the examples I'm going to have for you today stem from simple sketching. You know, how we dimension and constrain our sketches is kind of the fundamentals of building a 3D model, and it can have a huge impact on how it updates. But it's not just sketching, it's also features. You know, ink conditions are a great example, but also the feature types that we choose. You know, do we choose a pattern versus some other option because of how it updates? So I have a number of different examples, but we're going to start really simple. The first one here is a simple hinge, and if we take a look at this model, it's really very basic design here, where all we've got is a simple shaft going through the middle, and I have some holes cut through the hinge here, and very basic, simple hinge. And of course, with a hinge, I want to be able to configure this. I want to be able to build different sizes very quickly. So I've gone into the hole pattern, the hole for this hinge, and you'll see the 3 different hole types here. And what I want to illustrate first is how they're dimensioned. So you'll notice in this example, all the hole locations, this 3.5, this 2-inch dimension, are all relative to this bottom edge of the part, right? So this dimension in particular and the 3.5 are both referencing the bottom edge of the part. And while right now this looks as though it's symmetric, and it is, this hole is perfectly centered, and this hole is a 1/2 inch from the top edge, which is my intent, the way I got there is not correctly reflecting it. Right? So again, what I'm trying to illustrate here is, my goal with this is to have this hole centered in the plate and to have this hole a 1/2 inch from the top edge. But I'm using a 2-inch dimension and a 3.5-inch dimension to accomplish it. The problem with this is how it behaves to change. Again, right now, everything looks fine. And if I never made a change to this ever, I'd be okay. But inevitably, you will make a change. So what happens? Let's edit the extrude. Now, in this case, this hinge is driven. The entire thing is driven by the pin. So I have a number of different parts, including this center pin. If I make this longer, let's say 5-inch, okay, green check OK. Notice how it rebuilds. Notice the hole locations. Okay. Again, because I use dimensions from the bottom edge, the holes don't move. So my intent with this was, again, to have this hole centered in the plate and have this hole a 1/2 inch from the top edge, just like this hole. To correctly reflect my intent, I need to add different dimensions. And so that's probably one of the best tips I can give you to correctly reflect your intent. Make sure your dimensions do so. So let's get started. Let me show you what I mean. To get started correctly reflecting your intent, you'll want to make sure that the dimensions do so. And that means deleting the dimension that is, in this case, frivolous. It's just attached to the bottom edge. It does fully define it, but it doesn't accomplish our intent. I'll delete that dimension, right? Just left click and delete, and we'll add a new dimension from the top edge. And again, just like the bottom edge, I'd like this a 1/2 inch from the top. Okay. So now this hole location is correctly reflected in my intent. Now we can go over, the ability to eliminate the redundant dimensions with things like variables, for example. But for now, I'm just going to leave these as 2 1/2-inch dimensions from either edge. And no matter what height I change this hinge to, those holes will always be a 1/2 inch from the edge. But what about this hole in the center? As I mentioned before, this 2-inch dimension was centered, but it's not anymore because I've changed the height. So what I can do here is I can delete the dimension, and instead of driving it with a dimension, use construction geometry. In this case, a construction line. I'll select line, construction, move my cursor along the edge of the part, and you'll see the midpoint wake up. You'll see it just as I move the cursor right there. I've now hit the midpoint of that edge. And if I construct a horizontal line, I can now attach my circle coincident to that line. So now, no matter what change in height happens to the hinge, it's always attached to the center or to the midpoint. Okay? Green, check OK, and now I get the expected behavior. Now, of course, the real test here is what happens if, again, I change it. So let's do that. We'll, again, edit extrude, and I'll go from a 5 to a 6-inch hinge. Green check. And again, notice I get the 1/2 inch from the top edge on both, on the top and bottom hole, but still this hole is in the center. So correctly reflecting my design intent. And so important things to point out, you know, the dimensions, the way you dimension things can make a big difference in how it updates and how it handles changes. And so with a few simple dimension tweaks, I can go from making a design change with 5 or 6 or 10 dimension changes down to 1 or maybe 2. And so it's all a matter of saving time as I go in and update, and getting that, you know, correct behavior, the behavior I might expect. Okay. All right, so that's a simple dimension change. Now let me show you an example where it's not always so simple. Now, this part couldn't get any easier, right? A block with 2 simple holes in it, and these holes are symmetric, or they're centered inside of the block. Now, and initially when I see this and I just look at it as a single part, I think, okay, well, those holes should stay centered within the plate. So when I make a change, if I edit this sketch, for instance, and I change this dimension to 12, you'll notice the holes do not stay centered. Okay, again, because of the way I've dimensioned it, 1 inch from the top edge, 2 inches apart. There's no symmetry with respect to the rectangle. And initially you'd say, well, that's wrong. But it's important to keep in mind that it's all about the context that you're building in. Right? So initially this looks wrong, but it's important to point out that, you know, it really does depend on what you're building. So as I start to bring in other features of this part, you'll start to see that there's relationships that may not, you know, necessarily benefit from having symmetry or from having these holes centered. So here I have a top plate, another plate associated with it, and, you know, in this situation, having the holes referencing a certain edge and a certain distance apart makes sense, right? Because of the way it's constructed. So again, it's all about the context. You know, centering something isn't always the answer. You know, it may be in many situations, but sometimes you do want, you know, holes referencing a certain edge, because there always will be, regardless of the design changes. Good question. Can I use a percentage? That's a good question. I don't believe you'd be able to use it as a percentage. You know, you could do the math, you know, point whatever it is percentage to multiply. You can do multiplication, but if you type in 69, 70, 71, 72% of something, I don't know that that will be picked up. Forgive me. I think that you would need to multiply it times the amount, but you can do that. Okay, so again, distance from edge, you know, this example really just trying to illustrate that there is situations where it's not centered, but it is relative to a certain edge that makes sense, and that is the correct intent. So now let's talk about symmetry. Now, in the last example, in the hinge, I wanted the holes a fixed distance from top and bottom edge, right? And that's why I had fixed values on both ends. But what if I wanted symmetric behavior, where no matter what I changed it to, I wanted them centered a certain distance from the center of the part? So what I'd like to do is show you symmetry. Now, the example I'm going to give you here, there's a few things I want to illustrate with it. The first is, again, the fact that when you make a design change, the way you dimension makes a difference. So here I have this simple rectangular block with some bosses, and you'll notice right now the boss here is centered and the holes in the back are centered, right? So it has symmetry. However, if I change the initial extrusion that drives all of this, and let's just change this from 12 to say 14, and rebuild it, you'll notice immediately that it wasn't constructed with the correct design intent. Right? So when I make that change, all of a sudden the holes shifted over. These haven't moved, but the rectangle has. So the way it was constructed isn't correct. So let's go over a few different things that we can do here. So jumping back, the first thing is how this boss is constructed. So that's one of the first things I want to point out here. If I edit the sketch for this boss, notice the dimension scheme that I'm using here to define it. I'm using, again, a 4-inch dimension from the edge. Right? That means that when I make it longer, it maintains that 4-inch dimension, which is not my correct intent. So the first thing, easy fix here, delete the dimension, and you want to correctly constrain this. Now, there's a few ways you can do that. In my case, a construction line is an easy solution to this. All right, I draw a construction line from the midpoint of this, and I can attach that to, in this case, the origin, or the center of the bottom edge. But construction lines are one way of accomplishing it. But the important thing is, again, notice that as I drew that construction line, I woke up that midpoint of the line and snapped it to that. The important thing there is now the center of this rectangle is attached to the origin. And so no matter what depth I change it to in the future, it will update. Now, some other important things to keep in mind when you talk about doing this is what we call a symmetric relation. And the key thing with a symmetric relation is that it maintains symmetry about a construction line. So this is another scenario where, again, notice that as I'm defining my holes here, I'm doing it with a 1 inch from one edge and then 10 inches apart dimension scheme. And again, it's tying it to a single edge of the part. So what I can do is delete the 1 inch dimension. Again, I'll use a construction line from the origin, which happens to be in the center, okay, and use this construction line to create a symmetric relation. Now, the way we do that is with a reference to the center point. So I'll left-click center point, construction line, center point, and now choose symmetric. And no matter what the dimension I change it to, for instance, if I change this to 9, it maintains symmetry about that center line. More importantly, when I change the depth of the rectangle, it also maintains symmetry. Okay. So again, just the thing to point out there, by attaching everything relative to the origin, if the rectangle changes sizes, for instance, about the origin, all of this will update. Right? And that's the key thing that we get with this, with all these changes. Okay, so that is symmetry. The symmetric constraint, again, is a very powerful one because it allows you to center. It could be circles, could be lines, could be any geometry, any sketch geometry about a center line. And that will give you oftentimes the correct design intent to make those kinds of design changes. Good question. From origin, which happens to be in the center, did I miss that the base is dimension symmetric about the origin? Okay. Absolutely. This base is what's referred to as a center rectangle. Okay. So a center rectangle would put the base center point at the origin, and that's a good point to point out. That's the way I've designed it. Now, if you used a corner rectangle, for example, you might have to pick up more midpoints because you wouldn't be at the origin. It would be at the midpoint of an edge, for example. There would be solutions, but it'd be just a bit more work. But again, all about design intent. Okay, so The next example that I have for you is a very simple one, but for those new users, I think it's one that's worth pointing out. And I think it's, the common question of when do I use a dimension, when do I use a constraint? And for the new users out there, we often run into a scenario where it's an abundance of dimensions, a lack of constraints. And sometimes the idea is, well, I want to fully define everything, so I add a whole series of dimensions. But oftentimes the constraints are the more powerful tool to use to correctly reflect your design intent. So I have a few simple examples of this, but probably the most basic is, of course, just over dimensioning. A classic case where I've just added a whole series of dimensions to fully define it. That was my goal, and rightly so. I want to fully define everything, but the way I've defined it may not necessarily be my intent. And the thing I want to point out here, I call it tangency versus dimensions, but in this case, I've defined the radius, the depth, and both start and end points of arcs with separate dimensions instead of using a tangent constraint. And the problem with this becomes inevitable when you run into certain dimension changes, right? It becomes aired out. It gives you issues where it's no longer, constrained properly. So if we delete a dimension here and I change this, all of a sudden I get a break in the tangency that I was expecting, right? So I'd expected this arc to maintain tangent relationship between this line and this one. But because it was driven by a dimension, when I change the dimension, it no longer is there. So again, my intent with this is tangent between both lines. And I don't want to do that by defining it with a whole bunch of dimensions. It's better to go in and actually correctly add your relation. It's just an important thing to point out, especially for those new users, that an abundance of dimensions doesn't necessarily replace good constraints, because you'll still have a lot of effort when you go to make design changes. If I make a dimension change and then I have to make another dimension change to make sure that it's still tangent, I'm doubling my effort. And if I have 2 or 3 or 10 arcs in my sketch, that can become very cumbersome. So the tip here is, if you can use a relation, it's probably a faster in terms of how it updates and how it behaves to change. Okay, so again, the lesson there is use your constraints when you can. Let's move on to another one. This is a simple Revolve example, and it's just another example where I like to show, what happens when you make design changes. So here I have a simple revolve shape. In fact, let's just do this. Let's revolve it to show you the end result here. So I'll revolve this very simple part to create my finished profile. Now, what I'd like to do is, I'm building this simple flange. I'd like to build, maybe a dozen different sizes of this flange. And, this diameter, the inner diameter, this outside diameter, all vary depending on, the size that I'm working with. They all grow by a certain amount, so in different nominal dimensions, let's say. So building these different sizes, how I construct that initial sketch directly relates to how much work it takes to build each size. So let me show you what I mean. I'm going to edit this sketch. So let's just say that I have a finished flange at 14-inch diameter, and in fact I'll check final here so you can see the finished result. So 14-inch diameter, and then the inside diameter is 5-inch, and then this diameter here is 7-inch. I want to build a new 16-inch version of this, right? So I double click that dimension. Now I change it to 16. What's worth pointing out is, notice these diameters don't change. But in the case of a flange, those diameters should go up with the outside diameter. Or maybe it's all driven by the inside diameter. But my point in this being, when I build a new flange, I'd expect these diameters to change with this one. Right? And an easy way to do this is, instead of dimensioning it with diameter values, I'll delete these. And I'll add dimensions that are relative to the outside diameter. So we'll say 5.5 and 4.5. The important thing I want to point out here is notice that now that I've dimensioned it this way, rather than having independent diameters for each piece of the sketch, now when I change it to 18, notice it grows, right? We'll change it again, say 20, right? So I'm getting that consistent value no matter what I change it to. And so now I've taken, building my simple flange, for example, from 3 different dimension changes down to 1 when I want to build a new version. So it's all about how you handle your dimensions and how your sketch is constructed. And this is a very simple example, of course, but there's lots of things you can do to build design intent into the way you've laid out your dimensions or your relations. Okay, so simple example with a revolve. The important thing I want to point out there, how I construct my dimensions makes a big difference. Next example, that is use and through all. So up to this point, it's largely been dimensions and really sketch entities, relations and dimensions. So in sketching, what can we do to correctly reflect our intent? But it's not always the sketch. Oftentimes it can be the end condition you choose or even the feature that you choose to correctly reflect your intent. So let me show you a few other examples that I have. The first here is an example where I'd use through all. Through all is an end condition in the extrude command that allows you to extrude to the end or through all the part. And if the part updates, it'll automatically change with it. And let me explain why this is important. Here I have this simple arm, and I've designed it, and everything looks good up to this point. I've got this angled cut, real simple, circular bosses here. And if I look closely at this, in particular, if I look at how it's constructed, you'll see that this is, if I edit the second extrude here, I have this extruded cut of essentially just a triangle, and it's going symmetric, right? It's going in equal in both directions with a blind value of 1 inch, right? Just 1 inch value. The problem with that symmetric end condition, is it's driven by a single value, 1 inch. It doesn't update, it doesn't know that the part has changed, so that 1 inch value is static. It doesn't react to changes. So again, this is an example where the symmetric and then 1 inch value gets me in trouble. And let me explain why. So let's make a change. Again, all design intent is how it reacts to change. And let's make this thing bigger. Let's make this 2.5. Actually, let's go a little bit bigger. 3. I'll make this 1.5. We'll make this 1.25. So I'm building a whole new version of this thing, kind of on the fly. Let's just throw in some dimensions. So I built a whole bigger size of this thing. Green, check OK, and that is what I get for my end result. Right? Remember, we used a symmetric value 1 inch cut. So because the part is now bigger than 1 inch overall, it no longer works. Right? Or at least it's not what I was hoping for. Okay. So that's the first problem with this. You'll see that the cut, it doesn't go all the way through the part anymore, which isn't what I was expecting. It also doesn't extend all the way out to the end of the part. Right? So let's jump back a second. I'll do an undo. Let's jump back into this sketch. I'm going to edit this sketch. Now, you've probably heard at some point you really do want to fully define your sketches. And if I go into Sketch 2, I notice a big bright blue line here indicating that I do not have a fully defined sketch. So that's the second reason this didn't update. Right? Because the length of this triangle is not defined, it's not attached to the edge of this part. When the part got longer, it remained static. It did not change. Right? So important thing to keep in mind, in general, fully defined sketches are a good idea, and this is why. Because when you don't define it, when it changes, you'll need to come in and also change this as well. Now, a tip is you'll notice that the length isn't defined, but really I want to attach it to the edge of this radius, what's referred to as the silhouette. We can do that with the use command. Now, the use command is probably one of the most powerful tools that we have to reflect design intent. Use will convert any edges, faces of an existing part to sketch geometry, which is a very powerful thing, because if those faces, edges, whatever you used as a reference, change, the sketch geometry also changes. So I'm going to select Use, move my cursor over this radius, and if you look closely, you'll see a pink line appear. I'll left click, and it converts that silhouette to a sketch line. So now you'll see there's a sketched line there. What's nice about that is now I can constrain my triangle to that converted edge, right? And again, the sole reason to do this is now because it's attached to the outside edge of that radius. If that radius moves, the triangle will move with it. Okay. Now, that's one of the problems that we faced. So in this example, it wasn't just that it didn't extend all the way out, but it also didn't go out far enough. So the cut didn't go far enough. To solve that, we could use a different end condition. Real quickly, question. Is it possible to include formulas to relate one dimension to another? Absolutely. What I would do, and we're not going to cover it in this webinar, is variables. Create a variable. And you can link as many dimensions as you'd like to a single variable. And this gets into something that a little bit more advanced topic for the new user, but definitely very powerful for design intent. There's a few places you can use this where it's it will save you tons of time. So variables, it allows you to link one value. I can even subtract values from each other, but that's what I would look into if that's what your goal is. Okay, so I mentioned before, we've taken care of the fact that triangle was not extended to the edge of the part. Now we need to take care of the fact that the extrude was going a blind value of a 1 inch. It was just going 1 inch depth. It is symmetric, which means it's going both directions, but still the depth of that cut is only 1 inch. So rather than use symmetric as my end type, I choose through all. Okay. Now the problem with this, you'll notice immediately, is that initially it's only going one direction, right? You'll see that I've sketched this triangle right in the center of the part, and of course when I go through all, it's only going in the single direction. But we do have second in position as an option, right? So you can set second in position through all as well. Green check OK. And now I have the same part. This looks identical to what I opened and just showed you a second ago, but now constructed entirely differently will behave better when we add changes to it. So just real quickly, again, let's go in and make some changes. Let's make that 3. We'll make this 1.5, 1, and 0.5. Okay, so simple changes, green, check OK. Because I've constructed the design intent correctly, notice that I don't have those issues I was seeing just a moment ago. Right, the cut goes all the way through. The triangle angled cut extends all the way to the edge of the radius because I've correctly reflected my intent. Okay. So again, it's all about how you construct the sketch. Initially the part looks identical, but when you dig into how the sketch is constrained, how the features are defined, you can really see a big difference between maybe the novice user and the user that's had some experience and had some troubles with design edits. So, all right, moving on. The next example I have is a multi-part example, and the important thing I want to point out with this is it doesn't just apply to a single part. With Onshape, we can model multiple parts in the same part studio. So here I have a piston and some seals modeled in the same part studio. And if you haven't done any multi-part modeling yet, it's definitely got a lot of advantages. And one of the biggest is that I can build, for instance, an entire pneumatic cylinder and build different variations just by changing a few dimensions and have potentially dozens or hundreds of parts update all at once. So it is a very powerful modeling technique, but the important thing I want to take, just to take away from this is that all these lessons don't just apply to a single part. Here's an example where if I build the seals with the correct intent, they will automatically update as well. So let's show the problem here first. Let's go into the sketch. The first thing I want to point out is there's a number of problems initially with the way this sketch is laid out. One of the first that I like to point out is notice the redundancy in dimensions. Both of these grooves are the same width. In fact, the same seal goes in both of them. And yet I have two different dimensions to drive the width of either groove. This is a great example where I'm over-dimensioning and under-constraining. In this case, my true intent is to have those grooves the same width no matter what I change them to. So I'll delete the second dimension and then just set the width of each groove equal using the equal constraint. Okay. Now, when I change one dimension, both grooves will update. So that's another example of design intent where I'm eliminating a dimension and simplifying it. If I decide to change that groove width, I only need to change it in one place. Okay. Another example of this is the redundant 12-inch dimensions that you see here. You'll see I have a 12-inch dimension for this diameter and the same thing for this diameter. The reality is they should be all exactly the same across the board. So if I delete this dimension, you'll notice the diameter here is not defined. Right? Now the simple answer to this is just to make them coincident. Right? Select this line, the two coincident, and now I don't have to dimension them separately. Right? Now this one dimension drives everything. Okay? So those are just some things to point out with this sketch, just some ways that you can simplify using constraints to better reflect your intent. Now, let's make a change. Now this is where we start to get into some issues. If you remember, in fact, let's take a look at that real quickly. We also have seals in this piston. Now that was just the sketch for the piston. But if I go into sketch 2 here, you'll see I also have a sketch for the seals. The sketch for the seals has two circles that are revolved, right, to create the seal shape. And what's nice about them, they do have some design intent built in. They are tangent with the edges of the grooves, so the diameter is driven by the part. But notice the 5.875 dimension here. And this again is another static value, 5.875. If the piston diameter changes, this dimension does not change to update with it. So that's the problem. Here's our seals when I make a change to the initial sketch. So let's do that. So I jump back into my first sketch and let's change this from a 12-inch to a 10-inch piston with a 9.5-inch diameter grooves. Green, check OK. Notice my seals. Right, the seals did not change. And then, again, it's all because of the way I've dimensioned it. It's that 5.875 dimension. So let's jump back. I'll undo. Okay, back to a 12-inch piston. And let's go into that sketch for the seal and delete that dimension. Now the natural question here is, well, what's going to drive the location of these circles that drive those seals? And this is another situation where I can use the edge of the part. Right, so I'll select use and just convert the edge to sketch geometry. Then I can make the circle tangent with that line. Okay. So now, instead of driving the circle's location with a dimension relative to the origin, I'm attaching it to the edge of the part. Okay, of course the test here, green check, of course everything rebuilds, but the main test is if I change this, let's go back. So now let's make that same change. We'll change this to 10. And we'll change this to 9.5. Okay, notice the seals correctly rebuild. Okay. And again, because I'm building in a multi-part studio, I can build, this is a piston for a pneumatic cylinder, let's say. I can build the entire cylinder in a single part studio and then just change a few dimensions and build an entirely different size because everything's correctly relationed, right? Everything has the correct design intent. So my main point here is just keep in mind that you do have a lot of options for how you build things in Onshape. And one of the things I want to point out is even multi-part studios can have the correct design intent reflected. Okay, moving on. So that is again simple example, but the big thing there, multiple parts working together are all changing at once. The next example I'd like to give you is another in condition example. So in type is a big deal when we start talking about all the different extrude options that we have. I want to point out why it's such a big deal. So here I have this end cap, and I have these holes that I want to cut all the way through the end cap, right? So of course I select my sketch, right? Sketch 5. I'll do extrude, remove. Now, here's the thing, especially for the novice user, the new user just getting started. I want to cut, and that looks right, but it's not going deep enough. Okay, well, it says 1 inch. Let's change this to 2 inch, right? 2 inch. Okay, well, that now is going far enough. I hit the green check, and now everything looks good. And it's a very easy mistake to make. I'm just using a blind depth of a certain amount. And it may work at that moment, but when you change it, you'll find that it doesn't. Right, and you often have to go back and make another change to that depth. So again, a blind value or just entering a number is oftentimes, if you have an option to do something else, you're better off doing that. It allows you to reflect better your design intent. So what's the issue here? What happens if this goes wrong? Well, notice that I have a blind depth of 2 inches. The holes go through, but what happens if we decide to change this to, let's say, a 3 inch depth? Right? Notice the holes are no longer going through the entire thing, right? They're going 2 inches down, but in this case, because the depth of that flange has changed, it's no longer enough, right? So that's an example where a blind value doesn't make sense. So quickly we'll undo. Instead of using blind, this is another example where through all makes the most sense. You use through all, green check, and now if I edit, let's edit the extrude here, change this to 3 again. Through all will recognize the change and extend the feature through to the end of the part. Okay, so through the entire part. That's the way to think of through all. And it allows you to build better design intent. Simple example, I know, but the important thing is use your in conditions. Through all is a good one. Up to face, my next example, is another very powerful one. Up to part, very similar, but it allows you to build a lot of intent in your model so you don't have to make a lot of manual dimension changes later. Okay, so that is through all. You also, by the way, have the option, and I didn't mention this, so I have another example of this, for up to face. So I can choose up to face, for example, and select this face on the boss. And now the depth, again, is linked to the depth of that feature. So in this example, if I wanted the holes to go through all no matter what, both accomplish the same thing. But you also have that option, and it will then tie the depth of the feature to the face that you click on. Okay. All right, so let's go over another example of up to face. So in this example, I have a simple hinge. And what I'd like to do is, again, change the size of this hinge. The problem that you'll run into is the up to face in condition in this case is not applied. So let's take a look at this. If I go to the extrude for this inner piece of the hinge, okay, I have a blind depth of 1 inch. Right? And so this center piece of the hinge is a blind depth of these 2 circles up 1 inch. And although it looks like it perfectly matches the other part, and it does, this is bad for intent, right? I'm using, again, a blind value of 1 inch. Okay. Now, the problem here is the same as before. When I make a change, because of that blind value, let's change this to a 4-inch hinge, I end up with this gap between the feature and the other end of this part. Okay, so very important thing I want to point out here. Notice the blind 1 inch is maintained, but that creates an issue if I build a bigger size. Okay, now I have this gap that I then need to go in, edit the extrude, and say, okay, I want to make this 2 inches. So the better solution here, again, we'll do a quick undo. The better solution here is instead of using blind, we're going to use up to face. I'll select up to face. I'll select the face of extrude 2 here, right? This part, different part in the part studio, but that's fine. And now if that face moves, this extrude will move with it, right? So let's try that again. Again, initially it looks the same, so you can't tell a difference at a glance. It isn't until you change it. So again, change this from 3 to 4. It isn't until you change it, you'll see now I'm getting the correct intent. The boss is extruding all the way up to the face, even when I make it bigger. Right? So again, just something to be aware of. If you're entering a static value, it does not change. It does not behave or update to changes. Okay, so those are some examples. The big thing there is, it's not just sketches, or it's not just the way we lay out dimensions or constraints. It's also those end conditions that you choose, or even the feature that you choose. So let me show you what I mean by that. The next example is one where, for instance, let's say, I have this U-bolt, and to create the threads for this U-bolt, I have a linear pattern. Right, so just to roll back one step here, I have initially created a simple sweep to create the thread, and then I linear patterned that sweep to create the thread on this side. Right, now linear pattern is a very common tool. You use it a lot, I'm sure. It's just one of those things that it's very easy to create multiple instances of a part. The problem with linear pattern is, again, you're driving it with a single value. I want to pattern this distance or that direction, this distance, this many instances, right? So I have a single 1.5 inch value for how far I'm patterning. So from here to here is 1.5 inches, right? And so I know, that value is static. So if I hit the green check, let's just try this real quickly. That means if I change the distance between those two, in the U-bolt, the pattern will fail. So let me show you what I mean. Let's go back to the first sketch here. So here is the U-bolt. If you're familiar with the sweep tool, this is using a sweep to generate the U-bolt. So basic U shape here. And so there's that 1.5. I mentioned before the distance between those centers is 1.5. And that's what I punch in the linear pattern. The problem is, what if I change this? Right? What if I change this to 2? Green check. The first one will rebuild. The second one, however, does not. Right? The linear pattern patterns at 1.5 inches from the original instance. Right? So in this case, it's actually not working. It's not giving me the correct intent, because now I need to go in and edit the linear pattern and set it to the correct spacing. Right? So this is an example where it's not the sketch that the way you've defined it, or it's not the end condition that you're choosing. It's the feature. Linear pattern isn't intended to update, based on other things. So what we can do is, instead of using a linear pattern, in fact, let's just go back real quickly, undo. So everything's working correctly, right? We'll delete the linear pattern. So instead of using a linear pattern to pattern the thread over, I'll use a transform. Okay? The neat thing about transform is it has this option to translate by line. And so if you remember, going back to our first sketch, I have this construction line going from point to point. I can go part to transform. I'll choose the thread. Translate by line, I'll choose my line. Make sure to choose copy. In this case, I want to copy the part over. But the nice thing about this is now the part translation is defined by the line. If the line updates, the part translation updates. Right? Green check OK. Now I have the two parts. I can do my Boolean subtract and get my finished U-bolt. Okay, so there's my finished part. Now, again, it looks identical. You know, I had this just a moment ago, except it was driven by a linear pattern. The main difference here is if I decide to change from a 1.5 inch, and forgive me, I don't know the standards for U-bolts, so I'm just changing these dimensions, but I change it from 1.5 to 2 inch. Okay, automatically updates. Okay, so unlike the linear pattern, because the line changes, the transform changes, and all the subsequent features change, and I get a part that rebuilds automatically, instead of having to change the linear pattern and the sketch dimension every time I wanted a different size. So again, correct design intent. This is an example where linear pattern doesn't correctly reflect my intent, where a transform by line does, and it's a more powerful tool in this example. Okay. So again, not just how you sketch, not just in conditions, but also the features you choose make a difference. And a lot of times in Onshape you can do the same thing using one or two different tools. It just depends on your method and your approach. All right, one last example that I have for you, and that is planes. And this is another example where it's something that's easy to not correctly reflect your design intent. So it's not necessarily again, an in condition or something to that effect. It's, what type of plane are you using when you're inserting planes? So here's a simple part, and if you notice in this part, I have a groove cut right in the center. Okay. Now that is, of course, dictated by a feature, in this case, Extrude 3. And if I look at this feature, it's sketched right in the center of the part. So it's an extruded cut both ways. And it's driven on plane 1. Now, plane 1 is right in the center of the part. However, plane 1, if I edit it, is just simply an offset of another face. So this is another example where you can get into trouble. I wanted something that's exactly in the center of this part. But at this moment, the extrude is 1 inch wide. A 1/2 inch puts it exactly in the center at this moment, and that's the key thing. So I've used a simple offset 1/2 inch to build this plane. The problem is, of course, when you make a change, the plane does not update. So this is 1 inch depth. Let's change this to 1.25. Green check, OK. Notice no longer centered. Okay, and that's because the plane offset value is still a 1/2 inch. It doesn't know that the part is now 1 1/4 inches wide. So this is an example. Let's again undo back to 1 inch. Rather than use an offset of a number, use something like midplane, right? Where I can select two faces and it will center the plane between the two faces. Right? The beauty of that is when the two faces move, of course, the plane moves with it. Right? So the ultimate test here, again, everything looks identical. You can't see a difference, at least initially. It isn't until I change the depth. Let's extrude, edit. We'll change this again, 1.25. Same thing we did a moment ago. Green check. Notice the groove is still centered. Right? So that plane shifted because the overall length changed. So it's a simple example where choosing a different plane option better reflects my design intent and allows me to make one less change, or one less tedious dimension input when I do make a change like this. Okay. So the key things there, it's important to keep in mind it could be a different feature, it could be a different option. If you have a way to avoid entering in a static number and instead tying it to something else, you oftentimes can save yourself effort when you make a design change. And that's really what design intent's all about. So those are the examples I have for you. We have just a few minutes left. Again, I'm going to stick around and answer any questions that you have, so feel free to type them in. A few last minute things for you. If you're just getting started in Onshape, I really encourage you, try Onshape in your professional work and let us know what you think. There's a feedback tool built into the help menu in the top right. It's very easy to give us feedback, and we really encourage you to do so. We really encourage you to try it out and let us know what you think. Also, if you haven't shared your document yet, I definitely encourage it. A lot of the collaborative benefits, the real-time updating and the comment capabilities and the follow mode and all these neat things that we've built into Onshape are really directly tied into collaboration and sharing your document. So if you haven't shared a document yet, try it out. You can define permissions, so you can give them view-only permissions, or you can allow them to edit. So the last thing I want to mention is if you've been using Onshape a while and maybe you're interested in meeting local users, we'd love to hear from you. If you're interested in establishing a local user group, we'd love to help. We'd love to help you get things up and running. So that's it. That's what I had planned. I'm going to stick around again and answer any questions that you have, so feel free to type those in. But that's it. Thank you, everyone. Have a good day.